science, so that's always a good thing. I shouldn't say that really. Politics is important as well, but we're starting off with Nicola, who's going to tell us about a very interesting study about gender in physics examinations in Cambridge.
Thank you. I was asked during at lunchtime what I meant by longitudinal, and what I mean is that we're going to do, rather than talking about waves, I'm going to talk about the sort of study over a period of years. So, why we're doing this, so why did we look at this? Well, in final years exams at A-level, female students tend to do better or as well or better than their male counterparts. But when they come to university, that trend is reversed, and the male students do better. Certainly they get proportionally more male students get first than female students. So we wanted to have a look at why. So one thing, so maybe it's due to the, sort of the style of questions. At A-level, the questions are very, very scaffolded. They're broken down into many, many steps, whereas at A-level, they are, at university, they no longer are. And part of this reason could be that maybe female students, due to lack of confidence, struggle to know how to just get started with a question. So they, rather than the male students who may just throw themselves in and get going. So in the academic year of 2013-2014, Professor Val Gibson and Dr. Lisa Jardine-Wright asked all first-year students here at Cambridge to sit a mock exam in physics. And the mock exam was structured such that, so there are two examples of the exam paper, and for every alternating question, there was one question that was scaffolded. So we took questions from Tripos papers, from exam papers here at Cambridge, and we broke them down. They broke them down into sort of more scaffolded style of questions, and the other ones we left as they were, sort of the ones that we've called university style questions. And what they found that a greater proportion of female students found that the scaffolded questions just helped them to get a better grade. So we wanted to see whether this was repeated over the next 3 years. So we repeated the mock for the last 3 years, and to see how we followed the same structure, and also we wanted to look at how students progress, because now we've done it over 3 years. We have 2 cohorts who have actually gone from their first year all the way through to their third year, the end of their third year. So it would be nice to see how they progress. So let's look at the mock results aggregated over the 3 years. So you can really see that, so the grey is the results from the male students, and the orange is the female students. And you can really see this sort of two-piece. And if we put the means on there, you can really see that they're sort of separated quite a bit. You can see the females 52, the males 60%. So how does it look when we split up by question structure? So it's a little bit more disorganized, but if we put the means on there, you can see it's really quite shifted, with the female students doing worse than the male students. Now, if we look at this for the scaffolded questions, so these are still the mean for the university-style ones, and you can see that the mean shifts up for the female students. It also shifts up for the male students, but by not as much. For the female students, there's a shift of 10.3%, whereas the male students is 6.7%, and they are significantly different. So it really does, structured questions do really help female students a lot more than male students. So how does the mock compare with the results that we get in the mock? How do they compare with the first year exam? So you can see that we get this sort of similar trend in the sort of the number of firsts that we get in the mock versus the number of firsts we get in the first year exam. Here we get more thirds and fails in the mock exam than you do get in the first year exam, and that's probably because the mock is done in April, and this is probably a wake-up call for those who get thirds and fails that they should probably study, and so they tend to do better by the time they come to the exams. So let's break this down now for the university-style questions and scaffolded questions. So for female students, for scaffolded questions, you can really see there's a strong trend with more female students getting thirds and fails than they get firsts. But if we now look at the scaffolded questions, this trend is at least flattened. So now we get it sort of averaged over all of the different classes. If we look at the male students, you can see that it's sort of a bit more like a well in here. But then when we look at the scaffolded questions, you do see this trend as well, which is sort of pushed towards the sort of first class degrees. So this sort of really shows that scaffolded questions do help students to perform better, as you'd expect. But what is surprising is that it disproportionately helps female students compared to the male students. So let's now look at the progression to the end of the year exams. So I wanted to look at how many, if students do well at one question versus another type of question, how many of them actually continue on to do physics? Who continues on to do physics, basically? So for this shows the number of the class achieved in the mock and the number of students who've achieved that class in the second year of physics. So this is students taking double physics. So those are ones who are likely to continue on to do physics in their third year. And you can see for university-style questions, for male students, if you get first to university-style questions, you're more likely to go on and do double physics. Whereas female students, you can't really say anything. It's very flat. Whereas with the scaffolded questions, you get this trend of, if you're a male student, you get first in the scaffolded style of questions, you're more likely to go on and do double physics. But you get this trend also for female students, if they get first in scaffolded questions, they're more likely to do double physics, whereas they're less likely to choose double physics if they get 2-1 or below. This could be, I mean, we have to remember that at Cambridge here we've got the natural science system where you choose lots of different subjects, and so they may have chosen physics because that was one, they'd done it at school and they'd enjoyed it, but they'd never intended to continue with it. So how does this compare? So now, if we go back to how students do over the, as they progress through the different years. So this is the classes achieved in the first year exam, by the end of the first year exams. And what's striking is you can really see that female students tend to achieve more, they only outperform the male students in the 2-1, whereas more male students tend to get 2-1s and firsts. And it's really striking sort of this difference here, which is very, very stark. And so 20% of students receive a first compared to only 14% of female students, which is sort of quite worrying. But there's a positive here. As you go on in the second year, you actually get an improvement. So this is what it was in the first year. By the second year, the female students are catching up with the male students. And they're on a par here. By the similar number of 2-1s are gained by male students and female students. And the male students, you tend to see this also, they also shift up, but it's not sort of similar amounts. So the female students are catching up with the male students. So that is promising. The gap has been reduced, so it's now 39% for the male students and it's 42% for the male students and 30% for the female students. And by the time we get to the third year, the female students and the male students have more or less caught up with each other. There's maybe a little bit more here. The number of female students is quite low for every year. So the class difference is 20% of female students, this is 80% of female students in both second and third year. And so you can see that here, by the time we get to the third year, the female students have caught up with get as many firsts as the male students. And so the female students are catching up by the end of the year. It would be nice, by the end of their degree, it would be nice if they caught up within the first year as well. No. So the conclusions is that a greater proportion of female students found scaffolded questions to improve their overall class, more so than the male students. And but we still see the proportionally fewer female students achieve first-class degrees in their first year. What's interesting is that if you achieve a greater percent than 70% in scaffolded questions, then you're more likely to go and do physics. It could be that they feel that they've done less than, if they get below 70%, then they don't feel they want to continue on with physics, so they may be chosen to do something else. And then by the third year, the female students are performing as well, if not better, than the male students. So that's what's nice to see, is that although the female students maybe start start a little bit lower than the male students, they do catch up. And so by the end of the year, by the end of their degree, there's no difference between male and female students, which I think is really sort of quite nice. What's interesting, though, is that sort of within the number of students who choose to leave and not take physics between the first year and the second year, you would think, if we take that female students feel less confident and would choose a subject that they're good in, that's not actually the case. That there are about those who get 70 and above in first year in physics, only about 20% of them actually choose to do physics. And the rest of them, they go on and do other subjects. And that's generally because they've actually also got 70 and above in all of their other subjects. Whereas male students are more likely to choose physics if they've got 70 and above in physics. Whereas female students, whether they get a 2-1 or a 2-2, not that it's classified like that in the first year anyway, they're equally likely to choose physics. Whereas the male students, the better they do, the more likely they are to choose physics. So which is sort of slightly different to what you would expect if it's an idea of confidence. So yeah, so that's it.
Thanks, Nicola. It's a very interesting study, very, very revealing. Are there any questions? So there's one over there and then Rachel. No.
I just wondered if you got any more historic data, because I remember, it was nearly 35 years ago when I did my A-levels. They weren't as structured, the questions then. I just wondered if you actually knew whether females entering university sort of 30-odd years ago, whether there was such a difference.
I haven't looked at that data, unfortunately, but it would be interesting to have a look at that difference, because it was, yeah, as you say, it was less structured than it was than here. I mean, we've got a little bit of data from other countries who maybe don't, who structure. I studied in Switzerland. I grew up in Switzerland, and I know that our exams were a lot less structured than what they are like now, but then that was 15 years ago, so it may 15 years or so ago, so it's different. It's changed again quite quickly, I think.
So would you advocate changing the setting of the A-level questions to going back to less structured to help the females when they get to university?
Well, I work on the Isaac Physics project, so the answer would be yes. But I think it's, I think it helps, the way the questions have been structured so much, the way they're so structured at A-level, it does lead to disadvantage when they get to university, and they don't, all students struggle to know how to start even solving a problem which isn't structured. And so I think there is some things that at university we need to start teaching them again, how to break down a problem, how to solve it themselves, give them their own frameworks for solving it. And maybe, I mean, I think the exams have changed a little bit over the last 3 years that we've done the study, because I looked at, I can't remember exactly the exact numbers, but when we started the study, there were only about 10 or 12 possibly who are getting sort of 70% and above, whereas in the last year, in 2016, I think it was about, last year that I looked, it was about 30%. So there was 30 students. So it has increased, and so maybe we are starting to do something which is improving. But I think, yes, we should, and I think the exam boards are starting to shift back towards less structured.
Okay, so Rachel had her hand up first. I think we've only got time for one more question, I'm afraid. But... Oh!
So two things. One, to pick up on that question. In fact, we do have data. I produced a paper in about 2010 looking at 5 years previous data, or at least for 5 previous cohorts, all the way through from part 1A to part 3. And they all showed the same behavior, that there is a huge disparity in part 1A, more or less gone in part 1B, and by part 2 and part 3, essentially equivalent performance. So our hypothesis then, which I think is probably the same now, is that the women who are not particularly good at physics leave physics at part 1A, whether they originally, now we have the intention survey running for the last 3 years. That's an attempt to find out whether they always intended to leave or whether they've made their mind up on the basis of the exams. But my question related to the third bullet point, which I really don't understand, because although you say achieving 70% in scaffolded questions increases the likelihood, of course that can't be causal. I don't believe that students say to themselves, oh, I did some scaffolded questions, I did them really well, so I'm going to do next year. So that's not what's happening. And then I really don't understand why it is that students who do well in scaffolded questions, but not particularly those who do well in ordinary questions, are preferentially likely to go on to later year physics. Something bizarre in there, and I have no idea what.
Yeah, I probably worded that wrongly, that we do, yeah, we see a correlation, whether it's a causation, it's probably not a causation, but we do see that correlation between the two. But exactly why that is, I think we need to look into it a bit more as to why we see students who don't do as well at scaffolded questions choose not to continue, well, don't end up continuing with physics. So maybe it's just the type of student who continues to do physics, does better at scaffolded questions anyway, and regardless of whether they do okay at university-style questions or the sort of normal style of questions, maybe they haven't just got the hang of actually solving those.
Okay, so I think we should, I mean, this discussion could go on for a very long time, but we're on a very strict time schedule today for some strange reason. So let's thank Nicola again.